Hi, we are Group 1. We are going to present the technical report for this section. I'm Ming, and here's my group members, Hor Wai Keat and Mohniis Mahavir. And this was the table of content of our report. Okay, I would like to present the introduction first. So the instruction set architecture is the medium that is able to communicate between the high-level language and machine language. There are two popular type of instruction set nowadays, which is reduced instruction set computer, or we call it as RISC, and complex instruction set computer, CIS. So there was two major company that are using the CIS right now, which is Intel and AMD. Because most of their microprocessor right now, we can find the x86 architecture has been used in their processor, such as Pentium 4 or any other processor. Next, you can find got two major company also for the RISC architecture, which is Apple and Samsung. They are using the ARM architecture for their processor, such as Bionic A13 or an Exynos 2200. Other than that, the ISA can be implemented in 4 different type of addresses, such as 0 address, 1 address, 2 address, and 3 address instruction set. For example, most of the RISC are using the 1 address instruction, which is load, store, register, while most of the CIS architecture are using the both address, which is 0 and 1 address instruction, because we can find the stack pointer and accumulator register in the instruction set manual.
Hello, my name is Mohniis Mahavir Muralidharan. Firstly, I'm going to present about the definition of Open Power ISA. For the definition part, Open Power ISA is also known as Power Instruction Set Architecture, which is defined as a reduced instruction set computer, and in short, we will call it as a RISC. It was developed by the Open Power Foundation, which is the governing body for Open Power ISA, and it is led by IBM. Moreover, the name power is a name we call it in the past, and it means performance optimization with enhanced risk. It is an old microprocessor instruction set architecture designed by IBM. Power instruction set architecture is also known as RISC load or store architecture, and it is the latest instruction set combined by the PowerPC and PowerPC book E instruction set. Next, we will look at the importance of technology. Open Power ISA is used mostly in data storage devices, servers, supercomputers, and workstations by IBM, as well as other server manufacturers such as Bull and Hitachi. With the use of Power ISA, a soft core is developed by an IBM engineer, and it is running on a Xilinx FPGA. This newly developed software is mainly for the open source community, and this technology has become a reference design for other useful technologies such as Open Coherent Accelerator Processor Interface and the Open Memory Interface. Moreover, IBM also utilized the Power ISA in its Power Series chips as well as in many embedded devices that are produced by other production companies. This Power ISA helps the developers for moving the data quickly and also for developing new software application for AI and hybrid cloud build. Finally, for developing computational hardware, Open Power ISA is a type of instruction set that provides more option for dealing with it. Next, we will look we will be I will be presenting about the historical background of Power ISA. IBM is a company that manufactures and at the same time sells computer hardware and software to other manufacturers. IBM began working on the RISC architecture in the 1970s, and at the same time, IBM released the first Power architecture in 1990, which was a specific implementation of RISC action plan. IBM created Power family of the processor in the late 1980s, and in the long run, the name Power was upgraded to a new specification which is known as Power Instruction Set Architecture. Before evolved to Power ISA, the power instruction set architecture is evolved to PowerPC first and then only changed to Power ISA. The Open Power Foundation operates or maintains the open source Open Power ISA created by IBM in 2019. Then the administration of the Open Power Foundation handled by Linux Foundation. Power is a line of microprocessor invented by IBM and IBM Power sold it to other manufacturers to be used in servers and supercomputers. Power 8, Power 9, Power 10, which are often combined with Open Power ISA version, are product designation that are equivalent to Intel i5, i7, and i9. Moving on, this is the principle of operation of Power ISA. Single precision and double precision floating point operations are supported, and it also complies with the IEEE standard for floating point arithmetic. This is accompanied um, by a multiplication addition instruction and additional decimal floating point. Power ISA provides single instruction, multiple data operation on integer data, and floating point on up to 16 elements in one instruction. Moreover, Power ISA supports Harvard cache to split data and command cache as well as support for unified cache. It also allows for memory operations which are mainly for loading or storing, but it allows for out of order execution. Big endian and little endian addressing are supported in the Power ISA with separate categories for endian mode and per page, as well as it supports for 32-bit and 64-bit addressing. Lastly, there are many other modes of operation included in Power ISA such as user, supervisor, and hypervisor. Lastly, I'll be presenting about how does the technology work. In general, Power Instruction Set Architecture works as an interface between hardware appliances with the software. It is a part of a computer related to programming and it is more or less machine language. It provides some commands to the processor to execute tasks that is needed to be done by the programmer. For example, LibreSoC, which is the system on chip, is a 64-bit Big Endian Scala processor core and it sticks to Power ISA version 3.0 instruction set. The system on chip will integrate everything needed to power a small embedded system and equip it with open source hardware and software that works seamlessly with custom open source drives. For the basic architecture, we only need to execute 129 instructions to have a subset of scalar fixed points, which is the simplest storage that can comply with Power architecture. From there, we can add more instruction, for example, 214 instruction if we want to use scalar fixed point and floating point. Additionally, we can add more commands such as 962 commands to get the subset of Linux required by some other operating systems. There is a larger set of instructions which is 1099 instructions used in the AIX operating system. To get the full version of implementation of OpenPower ISA, we need 1419 instructions in total and we can build processor from simple to very complex devices. That's all from me. Thank you.
Thank you, Mohniis. I'm Hor Wai Keat, and I'll continue the presentation with technical specs. Open Power ISA is a RISC load and store architecture that contains variety sets of registers. It includes 32 by 32 bit or 64 bits of general purpose registers, GPRs, for integer operations. And it also includes 64 by 128 bits of vector scalar registers that contains 32 by 64 bits of floating point registers (FPRs) for floating operations, and also 32 by 128 bits vector registers (VRs) for vector operations. And it also contains 8 by 4 bits conditional register fields (CRs) for comparison and control flow. And last but not least, it also includes 11 special registers in various sizes, such as counter register (CTR), link register (LR), time-based TBU (TBL), alternate time-based (ATBU ATBL), accumulator (SEC), status register (XER), FPSCR, VSCR, SPEF, SCR. For support from industry, IBM Power10 processor contains powerful core that provides a new enterprise microarchitecture, and it is also AI infused. The processor is more flexible with support up to 8 threads per core or 240 per socket, and it is also optimized for performance and efficiency with the improvement of 30% average core performance, 20% average single thread performance, and 2.6 times core performance efficiency or 3 times a socket. In this processor, it also provides 4 times matrix SIMD acceleration, 2 times bandwidth and general SIMD, 4 times L2 cache capacity with improved thread isolation, as well as new ISA with AL data types. In terms of flexibility, it also contains multiple world-class software stacks that provides resilience and full-stack integrity for the chips of enterprise. At the same time, it also provides partition flexibility and security that are utilized in full core level alpha, thread-based alpha scheduling, and new processor with Power VM hypervisor. Now we'll continue with sample applications. Open Power ISA is being used in game consoles, solar system in the satellites, and supercomputer for network transfer and process large data. Retailers and healthcare systems around the world also rely on IBM Power for their mission-critical IT application. Banking sector also utilizes Open Power ISA to lower down costs, increase revenues, addressing government regulations, and business continuity. With IBM AS400 system, banks can store and secure business records, client data, and transactions against inside and outside breaches. With this system, banks can reduce dependability on IT resources and staff, which will also lower down the business operations costs, as well as a less complex banking business IT environment. This system also provides high-level services, reduce time spent on unnecessary tasks, minimize human error, and improve overall operations through automation. For existing implementations, Power ISA version 3.1 is the latest Open Power ISA with AI infused. In this generation of processor, it supports 64 bits prefix instructions, is RISC-friendly, and it also supports classic 32 bits instructions form. It provides new capabilities to existing instructions, such as new opcodes space for future expansions, and it also supports over 200 new instructions, such as 32-byte load and store, new AI accelerating instructions, and advanced system capabilities for cloud enablement with enhanced security measures. And that's all from me, and I'll pass the floor to Ming.
Discussion. By comparing to other instruction set, Power ISA got its pros and cons. For the pros, Power ISA provide various type of conditional branch, similar with the OpenMIPS and OpenSparkC, which having the capability on branching by checking the condition or status of the register. For example, the program can make a branch when there's an overflow or carry detected, while the RISC-V instruction set doesn't have this particular branch function, and they only provide the comparative branch method for the architecture, which compare both register that use it and branch it. For example, if both register are same or equal to 0, then it will branch to particular memory address. With these additional features, the program can be very flexible, but it did sacrifice the complexity of the architecture. Second pros, the Power ISA do support bi-directional endian for the user and consumer, while other ISAs did provide only little endian format. its predecessor, PowerPC, did support the Windows and Mac OS since the Windows are using the Little Endian format, while the Mac OS are using the Big Endian format. Other than that, the transmission control protocol, TCP or Internet Protocol IP, still using the Big Endian order to transmit the data from one to another. Hence, the function of the bidirectional can ease the difficulty when dealing with two different Endian order. This is the function that RISC-V instruction set doesn't come with. There's only one cons for the Power ISA. The Power ISA, it did provide many instruction sets for the consumer and the user, but it includes some variable length instruction which lead the architecture become more complex than the other instruction set, such as RISC-V, OpenMIPS. RISC-V and OpenMIPS still contain only fixed length instruction set which will reduce the complexity of the hardware. Since the Power ISA have more complex instruction set compared with the RISC-V, hence it will consume more power than the RISC-V architecture. And also this is the reason why most of the mobile technology companies such as Apple and Samsung have chosen ARM architecture over the Power architecture because its complexity and its consumption of the power. As we all know, the higher the power consumption, the higher the heat will be generated. Okay, here's the conclusion. Power architecture still taking the lead on the workstation and server industry, which the open power ISA still using on this particular area because this industry require high complexity on computing. Moreover, either workstation or server enterprise doesn't have to evade on using the more power consumption and cost more on the microprocessor since the microprocessor are reliable on security of data hardware. Next, summary. So basically, Open Power ISA is a RISC architecture which implemented in the power-based architecture microprocessor that developed by IBM company. Most of the power architecture has been used in the data storage device, servers, supercomputer, and workstation due to its powerful performance in security sector. Especially government-related department and bank enterprise has chosen the power microprocessor as their server and workstation device. For the Power ISA, it did provide various levels of the architectures to satisfy the user's needs, which was space architecture, scalar fixed point, and floating point subset, Linux subset, AIX subset, and always optional features. The user can choose the level they need for their project. The objective of the IBM is to increase the performance in the threads per core and the AI system, as you can see the implementation inside the Power 10 processor recently. But do note that the Power ISA did provide some variable length instruction for flexible purpose, which led more power consumption and more expensive. This is the reason why the ARM architecture had monopolized the mobile market nowadays since it was lesser power consumption and cheaper than the Power ISA. So the final part, future. Currently, IBM are focusing their production line on server and mainframe for the government-related enterprise, bank, insurance company, and etc. For example, 44 out of 50 top bank are using the IBM mainframe where it was using the Power architecture, which using the Power ISA. It is due to its security and the computing performance. Moreover, IBM just released the Power 10 microprocessor recently, which have reduced 50% power consumption from the Power 9 microprocessor. However, the Power ISA is not very recommended for the usage on the mobile technology industry since it having a bad performance per watt and price by comparing to RISC-V and ARM architecture. Lastly, the Open Power Foundation might work with the RISC-V architecture in the future based on the Linux operating system. And that's all for us. Thank you.